Humans utilize oxygen for respiration, making it crucial to their survival. In addition, oxygen is an important component of rocket fuel. 21% of the atmosphere on Earth is made up of oxygen. But, sadly, only 0.13% of the atmosphere on Mars is made up of oxygen. Not only that, but the atmosphere is less than 1% as dense as Earth's. Therefore, without a successful and dependable oxygen production mechanism, it is simply impossible to establish a colony on Mars. So, in today's video, let's discuss how humans will get oxygen on Mars. Presently there are two options for this matter. Option 1, MOXIE. In order to determine whether technology can supply the necessary oxygen for a human Mars colony, Michael Hecht built the MOXIE, a first-generation oxygen generator. It stands for Mars Oxygen In Situ Resource Utilization Experiment. The MOXIE has been the most popular and reliable option for in-situ oxygen production since 2014. It uses the fact that Mars' atmosphere, although lacking in pure oxygen, consists of 96% carbon dioxide. One carbon atom and two oxygen atoms make up each CO2 molecule, giving each one a net oxygen percentage of 72%. As a result, the MOXIE pulls in Martian air and uses a technique known as solid oxide electrolysis to electrochemically break CO2 molecules and liberate oxygen. The current standard MOXIE is a highly compact system. It measures 23.9 by 23.9 by 30.9 centimeters, which is comparable to the size of a car battery. Each unit may produce up to 10 grams of oxygen each hour, which is enough to maintain one human being. In fact, one was put into the Mars Perseverance rover in 2021. The rover successfully converted carbon dioxide into breathable oxygen using the MOXIE, verifying the claims of models, simulations, and experiments conducted by experts since the MOXIE was first developed. Even so, one must also take into account the high power requirement of this device because electricity on Mars will not be as easily accessible as it is on Earth. With MOXIE's success, researchers expect that future advances will be able to store oxygen, allowing astronauts to sustain themselves on the red planet while also providing a source of fuel for a return trip to Earth. Next. Option 2, brine electrolysis. A recent study showed that electrolysis of the Martian brine can effectively produce hydrogen and oxygen. This is important because there are soluble salts in the Martian regolith known as perchlorates, which have been described as global and ubiquitous across Mars. Even in dry places like Mars, these salts have exceptional water absorption capabilities. As a result, areas with high perchlorate are brine hotspots. These sites become potentially large sources of oxygen since this brine can be split into hydrogen and oxygen. Images from 2008 revealed droplets of brine that had collected on the struts of NASA's Phoenix lander. It was believed to be a solution of magnesium perchlorate, with the three images corresponding to days 8, 31, and 44 after the lander touched down in 2008. The perchlorate-rich site that was discovered accidentally shows how much there could be on Mars. Even so, there's a chance that this is an anomaly. More investigation will be required to confirm this. As was pointed out when talking about it, the MOXIE is a very inefficient system since it needs a lot of energy to produce oxygen. On the other hand, brine electrolysis is theoretically 25 times more efficient than MOXIE. In other words, it can generate up to 25 times as much oxygen with the same input power. This increase in efficiency would be invaluable in a self-sufficient Mars colony because almost every aspect of living will require electricity. By not using the MOXIE, additional energy could potentially be saved and utilized for these other processes, improving the feasibility of self-sufficiency. So, which one? In terms of performance, the brine electrolyzer is undoubtedly more appealing, and for many, this makes it the best option. But, MOXIE has an advantage because of its continuous popularity. However, on a self-sufficient Mars colony, it is imperative that all machines and technologies have the highest level of integrity possible, as they are what prevent colonists from succumbing to the inhospitable conditions of Mars. Thank you for watching and follow for more.